Okay, we will continue to discuss and work on the topic radar survey, and we will stop exactly on ground radar survey. On previous video, we discussed that this ground radar survey is used to determine the surface of the Earth and to see some errors. First of all, let's start our discussion from watching video. The length of this video is about 4 minutes. Please have a nice day. Just a minute, I will show.
Welcome to the Fundamentals and Theory of Ground Penetrating Radar by Geophysical Survey Systems. We will introduce you to the basic concepts of GPR, how it works, and how to interpret the data as it is displayed on your screen. GPR stands for Ground Penetrating Radar. It's an electromagnetic energy signal that penetrates through the subsurface. GPR systems are typically comprised of 3 elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated here. For example, the Structure Scan Mini contains all 3 components in one dedicated system. The antenna has a transmitter and a receiver. When the signals are returned to the antenna, we record a 2-way travel time and the amplitude of the signal. The amplitude is simply the strength of the signal coming back. Antennas come in various frequencies, depending upon your application. High frequencies are for shallow depth and small targets, ideal for concrete applications. Low frequencies are for typically deeper depth and larger targets, such as utility, geological, and archaeological applications. Survey areas with high conductivity can limit the depth and effectiveness of ground penetrating radar. An example of this would be clay soils or uncured or green concrete. Here is an example of objects or targets underground and how the data will be displayed in real time. As you collect the data, note the hyperbolas or upside down U-shape when targets are crossed at 90 degrees. When you back the antenna up, a cursor will appear on your screen. By bisecting the hyperbola with the cursor, this will mark the horizontal location of that target. Radar travels at different speeds through different mediums. A value is assigned to these mediums to represent different velocities of radar. This value is called dielectric. Dielectric is important, so the depth of targets or layers can be accurately estimated. Air has a dielectric of 1, which means radar travels fastest through air. Water has a dielectric of 81, which means radar travels slowest in water. Every medium in the world falls somewhere in between. Lastly, remember that GPR is electromagnetic energy. Other sources of electromagnetic energy, such as cell phone towers and 2-way radios, may interfere. These will not cause any damage, but may make it more difficult to see deeply into concrete or soil. In addition, unlike X-ray or other technologies, ground penetrating radar is not harmful and has no site restrictions associated with use. This brings us to the conclusion of the theory and fundamentals of ground penetrating radar. For more information on data interpretation and specific applications.
Okay, we have watched the video, and according to this video, we can say that ground penetrating is very beneficial because before building the building of some buildings or civil engineering, first of all, we should check and examine the surface of the Earth. Now let's again to return to our topic, and we will start to discuss about the presentation. We will continue to talk about radar survey now. On the next slide, you can see that radar images are informative on studying the structural forms of the lithosphere. If they are expressed in the relief, emphasized by a change in the lithological composition of rocks or zones of change in hydrogeological conditions. Faults and cracks are well recorded on the radar image in the form of extended lines. if the strike coincides with the direction of the aircraft. Low shooting angle allows you to use the shadow effect to highlight structural elements, and space radar surveys are the most informative and regional geological method, since radar images reflect generalized structures and cover large areas. The radar image is formed by a light spot running along the line. The terrain area is located directly under the aircraft, and the aircraft doesn't fall into the area of the radio signal and forms a dead zone, the size of which depends on the flight altitude and the angle of location. And here we can see that their severity of the radar image depends on the degree of roughness. And next slide, you can see that it's multi-area aerial photography. We know that we have single road aerial photography and multi-road aerial photography. It's as an example of this multi-area aerial photography. Multi-zone surveying can be used on surveying and designing of various engineering structures in difficult terrain conditions. Multi-area aerial photography can be done with one camera or with several cameras connected together and working with different combinations of aerial films or filters. For example, aerial photography in the wavelength zones of 0.38 or 0.46 microns is formed to determine the state of crops and foci of their diseases. Multispectral surveys are carried out to study the species composition of woody vegetation or the degree of moisture content of soils and rocks. In areas of landslides, they are carried out with spatial interpretation of aerial photographs. It's the end of the presentation what I have prepared for today's. Please study this information more carefully because you will need it on doing the tasks. Have a nice day. See you.